We all remember trigonometry from school, right? Triangles, angles, SOHCAHTOA. But what if I told you there's a hidden rule, this fundamental secret that unlocks its true power? It's something that most of us, and yeah, even university STEM students, completely miss.
And I'm not kidding. Everything you might have memorized about finding the height of a building is, well, way less important than this one single idea. So let's dig into it.
Okay, so to find this secret, we first have to kind of unlearn what we think trigonometry is all about. We've got to move beyond the high school classroom. Because if that's what pops into your head, you're definitely not alone. But honestly, that's just a tiny, tiny piece of the puzzle. This is ground zero for pretty much everyone. Good old SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, you remember. And it's handy for sure if you need to find the length of a ramp, but it feels pretty limited, doesn't it?
I mean, how on earth do you get from that simple triangle to all of this? How does it connect to the realistic motion in a video game? Or the sine waves that create digital music? Or guiding a plane through a crosswind? Or even calculating a bullet's path at a crime scene? The link just isn't obvious, is it?
Well, that connection, the secret sauce that unlocks all those applications, it comes from shifting our whole perspective away from the triangle and over to the circle. It turns out the circle has its own natural language. So here's the crucial idea, that right-angled triangle is really just a tool we can draw inside of a circle. The real engine of trigonometry is the circle itself. And circles, they have a preferred way of being measured that has nothing to do with the kind of arbitrary 360 degrees we got from the ancient Babylonians.
And that language is the radian. And it's a beautifully simple idea. A radian is just the angle you get when you take the radius of a circle and you lay that exact length along the edge of the circle.
So you see, a radian isn't some random number we just made up, like 360. It's a natural property of every single circle in the universe. The circle is literally describing itself using its own parts. It's just the ratio of a piece of the edge, the arc length, to the radius. That's it. And that makes it a totally universal unit of measurement. And this natural quality, that's everything. Because radians connect angles directly to distance and motion, they become this essential bridge between the abstract math of circles and the real-world physics of waves and vibrations that govern our reality. And once you start thinking in radians, you begin to see that trigonometry isn't just some niche math topic, it's a fundamental language for describing the world all around us.
And this has been true for centuries. Ancient astronomers used it to map the heavens. 19th century engineers used it to build our entire modern world. Physicists figured out that sine and cosine are the perfect language for describing all kinds of waves. And today, programmers use those exact same functions to create realistic graphics and sound. I mean, the applications are just incredibly diverse. Criminologists use it to reconstruct events. Pilots rely on it for navigation, constantly calculating how wind is going to affect their actual path. It's the hidden calculation engine behind so much of what we do.
But here's the twist, and it's a big one. Despite how absolutely necessary radians are for all of this, there is a massive global blind spot in how this is all understood. So let's do a little pop quiz to see this blind spot in action. Now don't worry if you haven't taken calculus, a derivative is basically just a way to measure how fast something is changing. The question is simple. What's the derivative of sine of x? And the answer that just jumps into your brain is, of course, cosine of x. It's one of the first things you learn in calculus. But there's a critical piece of information missing there. There's a catch. So here's the real question. Is that clean, simple formula, the derivative of sine of x equals cosine of x, true if x is measured in degrees? Or does it have to be in radians? Or, maybe it works for both. The answer to this is the hidden rule. Well, according to a multinational study of university STEM students, these are the people who are supposed to know this stuff. Over 70% get this wrong. They assume the formula just works for both. And this isn't some minor mistake, it's a huge misunderstanding. And here it is, the hidden rule in plain sight. That simple, beautiful formula, the derivative of sine x is cos x, it only works when x is in radians. If you try to use degrees, you get this ugly, clumsy conversion factor, pi over 180, just bolted onto the side. All the mathematical elegance just vanishes. Now, you might be thinking, okay, so it's a messy formula with degrees, who cares? But this isn't just about making math look pretty on a page.
It has profound consequences for how we describe the universe.
The most important equations in physics, the ones that describe waves, electricity, quantum mechanics, they are all built on that simple radian-based formula. They fundamentally depend on that rule being true.
Just take a look at the formula for simple harmonic motion. It might look intimidating, but it's basically the mathematical heartbeat of the physical world. It describes everything from a pendulum swinging to a guitar string vibrating to a light wave traveling through space. This entire elegant equation is built on the assumption that everything inside that cosine function is measured in radians. If you try to plug in degrees, the physics would just completely fall apart. And that is the ultimate takeaway here. The reason calculus demands that we use radians isn't some random choice by a bunch of mathematicians. It's because radians are the natural language of circles and waves. And to describe the universe accurately, you have to use the language it's actually speaking. Which brings us to this really powerful idea from physicist R. Shankar. He said in alien civilization, they might not divide a circle into 360 degrees. That's our thing. But because the ratio of a circle's circumference to its radius is a universal, unchanging constant, they would inevitably discover the concept of 2 pi radians. It's a fundamental truth of the cosmos just waiting to be found.